Honors Algebra 2, Chapter 8, Section 5. We're going to look at how to add and subtract rational functions. But before we do that, let's review how to just add and subtract fractions in general. And so here if we have 2 fourths plus 3 fourths, we add the numerator to get 5. The denominator stays the same as 4. And then if we're adding that do not have the same denominator, like down here 2 fifths plus 3 fourths, we need to make them common denominators, so like you multiply the bottom and the top of the same number to so 5 and 4 become the same number, so common multiple. So 5 and 4, the first number that both 5 and 4 go into is 20, so then 5 times 4, so we need to multiply both the top and bottom by 4 there, and this will multiply the top and bottom both by 5. And so we're really multiplying by a value of 1, so we're not changing the fraction, but we change the numerator denominator. So 8 twentieths plus 15 twentieths. So then we can add the numerators, so we get 23 twentieths. And same thing works with subtracting. And so let's do this top one up here, because a lot of students will do 6 times 4 to get 24, but it's not the common, least common multiple. We could actually just multiply the bottom here by 2 and the top by 2. So we have a common denominator of 12, and multiply this one by 3 over 3. And so then we get 10 over 12 minus 3 over 12. So we get 7 twelfths. In today's lesson, we'll be doing the same exact thing, except we'll be doing it when our numerator and denominators are polynomials. There's some rational, there's some expression. And so here, when we're adding this fraction, they have common denominators. So we can just add the numerator here. And we cannot add that, so we write it 3x plus 6 all over x minus 4. After you do that, we still need to look to reduce. How at the top we can factor out of 3 and to see if it reduces anything in the denominator, but it does not. So that would be the final result. Down here, they do not have the same denominator, so we need to find a common denominator. Both 6 and 8, first number they both go into is 24. So I want to multiply the bottom and top of this one by 4, and this one multiply by 3. When you do that, you have to multiply the entire numerator by that value. So the fraction becomes 8x plus 20 all over 24 minus 3x minus 21 all over 24. Then when we're subtracting, be careful, because we're subtracting that entire quantity. So 8x minus 3x is 5x. And then 20 minus a negative 21 is really positive 41. All over 24. So that would be the result. So some of these become a little more difficult. And so to help us out, you may want to factor the numerator and denominator to help you see what parts make up each of the denominators. So you can see in this fraction here, x plus 3 is the denominator there. We can't factor anything out. But for this one, we can pull out a 2, and we're left with 2 times x plus 3. So the first fraction, the denominator, is missing a 2, multiplied by 2 to make it become the second denominator. So we only need to multiply the first fraction, the top and bottom, by 2. And so we get 6 over 2x plus 6 minus 5x over 2x plus 6. So then we can subtract the numerators. So it's 6 minus 5x all over 2x plus 6. And we cannot reduce the 6's, we cannot reduce any of these x's, because the numerator and denominator have these addition and subtraction signs, which ties these operations together, these terms together. This one down here, it's factor, we get x minus 3 times x plus 3. And so the first fraction has both of these. The second fraction only has x plus 3. So we need to multiply the top and bottom both by x minus 3, that entire quantity. So we're still multiplying by a value of 1. It just happens to be a binomial on the top and bottom. So then the problem becomes 9 over x squared minus 9 plus, I distribute the 3, I get 3x minus 9 over x squared minus 9. So if I combine like terms of the numerator, 3x, 9 plus a negative 9 is 0. So 3x over x squared minus 9 will be the final answer. So for this example, there's no factoring that can be done. So I actually need to multiply. The first one needs the x minus 2. It doesn't have x minus 2 as part of the factors in the denominator. The second fraction needs an x plus 4. So we can multiply that out and we get 4x minus 8 in the numerator. And then we could FOIL the denominator. So we get a common denominator, but here's each individual denominator. Be x squared plus 2x minus 8. And then minus, distribute the 7. 7x plus 28. And then we have the same denominator. So we can combine like terms in the numerator. Be careful of your negative sign. So negative 3x, but negative 8 minus a positive 28. So it's more negative, so negative 36 all over x squared plus 2x minus 8. And that'll be it. Now down here we can look for the common factors. I would actually start with the second fraction factor that. I would pull out a 2x, and I'm left with the x plus 2. And the first one here, I can see, can I break up 4x squared to use any of these factors? So 4x squared is 2x times 2x. And so now I see how it contains one of these 2x's. So now in the first fraction, we still need to multiply by x plus 2 on the top and bottom. On the second fraction, it has an x plus 2, it has a 2x, but we need two 2x's. So we need to multiply by another 2x. So we can rewrite the problem, multiply the 5 through this parenthesis. We get 5x plus 10. Now, our denominator is going to be these multiplied out, which is really like 4x squared times x plus 2. So we get 4x cubed plus 8x squared. And then plus x plus 1 times 2x. So we need to distribute that. So we get 2x squared plus 2x. All over that same denominator. Combine like terms. I have 2x squared plus 7x plus 10 all over 4x cubed plus 8x squared. Now, before I call this it, I've got to be careful because we have a new numerator here. We've added like terms. So this numerator, this trinomial, we might be able to factor something that reduces with this new denominator. And so you might want to check that. We can't pull a 2 out and say, does that factor? Like, it does not factor, so we can't do any reducing, but you should just have that thought process. Can you factor anything to find the common factors on top and bottom reduce? They only reduce when you change the multiplication and then factors reduce out. Okay, last two problems, a little more difficult here. In these problems, we have the fractions within the fractions. So we have two things going on. We have the fraction within a fraction, and then we also have a sum or subtraction, depending on the problem, in the denominator or numerator. So we got to do both things. We need to add these fractions, and we need to get rid of the fraction of the fraction. You can do this in either order. Like for instance, in this one, because they have common denominators already, I would write that as one fraction. On the denominator becomes, combine like terms in the numerator, be x plus 5 all over 15. Now to get rid of this fraction within a fraction, that's the same thing as 8 over 5x divided by x plus 5 over 15. So this is really a problem from last section where we don't divide here. We actually want to change it to multiplication. So we multiply by the reciprocal. Look to reduce first. So 5 here reduces with 15, so we have 3 left over. And then multiply, the numerator is 24. Distribute the x, so we get x squared plus 5x. So that would be reduced. So we first added the fractions in the denominator, then we got rid of the fraction within a fraction. For the other problem, I'm going to do it the other way. I'm going to actually first get rid of the fraction within a fraction. I tend to like to do that first. This is my personal preference. And so what I end up doing is actually multiplying the top and the bottom both by the common denominator. And so the common denominator here is not just x plus 1. It's got to be both 3x times x plus 1. And so I would just write it out like this. Multiplying both the top and the bottom by that. So when I distribute this quantity to this fraction, the x plus 1 and this x plus 1 reduce out. So I get 2x times 3x, which is 6x. On the bottom here, I have to distribute this. So it gets multiplied to this first fraction, and it gets multiplied to the second fraction. When we multiply to the first fraction, the 3x reduces out with this 3x. I still have to multiply the x plus 1 to the 1, and I get x plus 1. Then I have the addition symbol here. Don't lose the symbol addition. Of the quantity. Now, when I multiply through by this quantity to the second fraction, the x plus 1 reduces the x plus 1. So I have 2 times 3x, which is 6x. Now on the bottom, I can just combine the terms. I get 7x plus 1. And I cannot reduce there because I have that plus 1 that ties it together. So this will be the final answer. Now, if you decide for this problem that you would rather, if you would rather add fractions first here, you can. This fraction by x plus 1, multiply this one by 3x. So we get x plus 1 over 3x times x plus 1 plus 6x over same denominator and then this numerator has not changed. So now I could actually add the denominator becomes 7x plus 1 all over 3x times x plus 1. Then I need to rearrange that by multiplying by the reciprocal over 7x plus 1. Then I look to reduce out, and I have the x plus 1's reduce out. So I multiply the 2x and the 3x, I get 6x all over 7x plus 1. Same answer. And so it doesn't matter which method. The first way I usually prefer, if I don't have common denominators. I feel it's less work for me, but either way would work. And as you can tell, I'm losing my voice, so I'm going to call it good for the night, and we'll see you tomorrow.